Hello, today I will explain my answer for question 2, secure cloud network for FinTech API. In this scenario, a FinTech startup provides mobile payments API from the cloud. The customers access API from the mobile applications, while internet staff needs secure admin access to maintain the screen, maintain the system, face API problems and support customers. Company also has an on-premises accounting system that receive transition summaries every night. The most important requirement is that customer data can be stored on premises only in Thailand. So my design uses a hybrid cloud architecture as the same as question 1. The main idea is that the cloud handles the public API layer, scalability, WAF protection, DDoS protection, API gateway, auto-scaling, monitoring, and backup. However, the sensitive customer database and the accounting system remain on premises only in Thailand. The cloud and on-premises systems communicate through a side-to-side IPsec VPN. So private data traffic does not travel openly over the public internet. Now I will explain the diagram from the left to right. On the far left, the public customer edge. On the far left, I have the customer mobile application. The user connects to the FinTech API using HTTPS, TLS, preferably TLS 1.3, so that payment information and login data are encrypted in transit. This helps protect against dropping, especially on public Wi-Fi or unsafe networks. The request first reaches the public customer edge. In this session, the traffic goes through secure DNS and CDN edge, then DDoS protection, and then the WAF and API threat protection layer. These controls protect the public API endpoint before traffic reaches the application. DDoS protection absorbs large traffic floods, while the WAF and API threat protection helps detect SQL injection, malicious payloads, abnormal requests, and bot-like behavior. After this, the requests go to the API gateway. Inside the cloud API and security control area, the API gateway is very important because it becomes the main control point for all API endpoints. It checks the access tokens, validates API permissions, applies rate limits, checks request size, and forwards only valid requests to the internet load balancer or API service. At the top of the cloud area, the diagram shows the cloud identity provider using OAuth 2.0 and OpenID Connect. This part supports the test 2 question. The mobile user authenticates once through the identity provider. After a successful login, the application receives an access token and refresh token. Then the mobile application can use the access token to call different API endpoints, such as payment, balance, transfer, transaction history, and customer support. The user does not need to log in again for every endpoint. The API gateway validates the token each time and checks the scope and rules before allowing the request. The diagram also shows MFA and token issue. And you can see in here. And refresh token flow. This is important because the user session should be secure but stay convenient. Access token should be short-lived, and refresh token should be rotated. If a device is suspicious or stolen, the system can revoke the refresh token and force the user to log in again. Also, in the top cloud session, I have the threat detection and geo rig engine connected to like Google Map. Go to the Google Map location history. This part supports test 3 before allowing sensitive API actions such as money transfer or edit a new beneficiary. The API checks whether the user is currently in Thailand, and it also checks whether the user has traveled to restricted country within the last 3 months. Based on user context API Google Map location history. If the user is outside Thailand or has restricted travel history, the API blocked the request. To avoid location spoofing, the system should also compare GPS, IP, geolocation, same country, device time zone, device integrity, and impossible travel signals. In the middle of the diagram, API service. In the middle of the diagram, the API services are placed in multiple zones such as API service zone here, like this, API service zone A and API service zone B with an auto-scaling API cluster for payday scale out. This is required because the Fintech API must always be available and must handle ultra-high load during end-of-month pay dates. The application services should be stateless so that the load balancer can distribute requests to any healthy instance, and auto-scaling can add more actions when traffic increases. When the API needs customer data, it does not connect to public database. Instead, the traffic follows a private path through the cloud firewall and security group, then to the cloud VPN. And then through the encrypted side-to-side VPN into the premises environment. On the right side of the diagram, on-prem system, Thailand. On the on-prem firewall NAT and on PREM accounting system. This defines the requirement that customer data must stay on premises in Thailand. The database port is private and only approved cloud application traffic is allowed to reach it. The diagram also shows nightly transition summary flow. Every night, the Cloud API platform prepare transition summaries and send them over the private VPN to the on-premises accounting system. This flow should use service account authentication, encryption, retry login, and audit login. If the accounting system is temporarily unavailable, the queue can store the summary until delivery success. At the lower left side, there is an admin access zone. Internet staff do not directly connect to API servers from the public internet. They use secure path, VPN, MFA, and PAM. Like this. Then access a Bayesian or GEM server. Admin sessions are audited and sent to SIEM. Like this. This protects against credential theft because a stolen password alone is not enough to control the protection system. In the lower middle area, the diagram shows monitoring and incident response. The SIEM and SOAR monitoring system receive logs from the WAF, API gateway, application, VPN, firewall, identity provider, database, and backup system. SIEM is used for investigation and correlation. SOAR perform automated actions such as blocking an API key, revoking tokens, disabling suspicious accounts, blocking malicious IP addresses, and creating incident tickets. This help detect the dropping attempts, SQL injection, DDoS behavior, credential abuse, and threat events. At the bottom of the diagram, I have the backup and disaster recovery. On prem database is backup to an on-prem backup repository and a physical secondary site backup. There is also a backup VPN gateway to immutable cloud object storage with object lock in Thailand, and a clean recovery environment. This backup design is important because the exam requires cloud backup, physical secondary backup, and at least one backup that attackers cannot easily delete. The immutable object storage provides that protection because object lock or warm retention prevents modification or deletion during the retention period. In conclusion, this design satisfies all three tests. For test 1, it provides a secure and highly available hybrid FinTech API architecture. For test 2, it uses OAuth 2.0 OpenID Connect with PKCE, so mobile user authenticate once and use all API endpoint through access tokens. For test 3, it uses a threat detection engine that checks whether the user is in Thailand and whether they visited a restricted country in the last 3 months using context Google Map location history. Overall, the design protects confidentiality, integrity, availability, authentication, authorization, accountability, and time data residency environment. Thank you.